Hello students, hope you all are doing good. Now we'll solve a question in chemistry. Okay, so this is the question. Give the correct order of initials, true or false, for the following statements. So there are four statements given in the question, and we have to find out those statements are true or false, and after that we have to write in the order like TTFT means true or false to true. Which one is correct, that we need to find out. We have got four options. So first statement goes like this: number of electrons having L is equal to 0 in 10 is 10 in palladium. In palladium, the number of electrons having L value equal to 0 is 10. This is the first statement. Now, second statement is the value of Z effective nuclear charge for 3D electron of Cr and 3D electron of Mn is same as number of electrons in D subshell of chromium and manganese are the same. The question goes like that. Effective nuclear charge, that I will explain. Effective nuclear charge of 3D electron of chromium and 3D electron of manganese is the same because they both have equal number of electrons in D subshell. That is the second statement. The third statement is multiplicity of Fe is equal to that of Ni2 plus. Multiplicity is nothing but spin multiplicity. So spin multiplicity of Fe is equal to that of Ni2 plus. That is the third statement. Fourth statement comes like this: value of L by N for the last electron of element of atomic number 57 is 0.4. Value of L by N. L means azimuthal quantum number, N is the principal quantum number. So L by N value we have to find out, and the last electron, okay, of the last electron of the element of atomic number 57. Okay, the element which is having atomic number 57 is nothing but lanthana. Okay, so we have to discuss these points. Okay, so we'll discuss one by one. Okay, now the first statement goes like this: number of electrons having L equal to 0 is 10 in palladium. So for palladium atomic number is 46. Okay, configuration goes like this: 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 5s2, 4d8. So according to above principle, this is the configuration of palladium. But you know, this is partially filled. So always completely filled orbitals are stable. So palladium attain another configuration which is 5s0, 4d10. So this is a stable configuration of palladium. So it comes like this: 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 5s0 and 4d10. So this is the stable configuration of palladium. Now in the question it is given as L is equal to 0. Okay, so we have to consider only S subshell. Since L is equal to 0, we know that we have to consider only S subshell. So how many S subshells are there? How many electrons are there? 1s2. There are 2 electrons here. Again here 2 electrons. Then here 2 electrons. Then again here 2 electrons. Okay, so 1s2, 2 electron, 2s2, 2 electron, 3s2 again 2 electron, 4s2, 2 electron, 5s0, there is no electron. So the total number of, since L is equal to 0, we have to consider only S subshell, and total number of electrons of S subshell is equal to 8. Okay, so we have got 8. So what was given in the question? It is saying as 10. but we got it as 8. So that means the first statement is false. First statement is false. Is it clear? Okay. So if you want, I'll explain once again. This is the stable configuration of palladium. Since L value equal to 0, we have to consider only the electrons of S subshell. There are total 8 electrons of S subshell: 1s2, 2s2, 3s2 and 4s2. So the number of electrons having L equal to 0 of palladium is not 10, but it is 8. That means this statement is false. Okay. Now we'll discuss next point. Okay, the value of Z effective nuclear charge for 3D electron of chromium and 3D electron of manganese is same as number of electron in D subshell of chromium and manganese are the same. Okay, so to explain effective nuclear charge, we should understand what is effective nuclear charge, what is screening effect, what is shielding effect. All those things you have already learned. So I'll explain once again. Like, see, if it is the nucleus, we have shells which contain electrons. Okay, so in the first subshell, we have got, suppose we have got 2 electrons, and in the second subshell, we have got, let us assume that it has got 6 electrons. Okay, so we know that nucleus contains protons, and there will always it will be an attractive force with the proton of the nucleus and the electron. But see, if the proton is attracting the electron from the outermost shell, the innermost shell which contain electron will have a problem. They will shield. Okay, they will shield the attractive force. That means the effective force will be lesser due to the shielding effect. And there is one formula to find out the effective nuclear charge, which is nothing but Z effective is equal to number of protons minus shielding effect. Okay, Z effective nuclear charge is nothing but number of protons minus shielding number of electrons in the innermost shell. So in this case, sigma is nothing but 2 because we have got 2 electrons. So for this electron, okay, let it be suppose 1, 2, 3, 4, 5, 6, 7, 8. So number of proton is 8. Okay, so number of proton is 8. Now inner shell we have got 2 electrons. So effective nuclear charge is 6. Okay, this is an example. Now in case of chromium and manganese, so chromium atomic number 24 and manganese atomic number 25. So chromium, if you are writing the configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, 4s1. Okay, 10, 24. Okay, now 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, 4s2. This is the configuration of manganese. Now in the question is given as 3d electron. We have to consider the effective nuclear charge of 3d electron. So we have to consider effective nuclear charge of 3d electron. Now as we know, the effective nuclear charge of 3d electrons. So since chromium and manganese have same number of electrons in the 3D shell, whether its effective nuclear charge is same or not, that is the question. So we have already discussed effective nuclear charge. We have a formula Z effective is equal to Z minus sigma. Okay, so Z, what is Z? Number of protons. So we will calculate effective nuclear charge for chromium. So Z effective is equal to number of protons for chromium is 24. So what is sigma? Sigma is this one, 2 plus 2 plus 6, 10, 10 plus 6, 16 plus 2, 18, minus 18 is equal to 6. So effective nuclear charge for the 3D electron of chromium is 6. Now we will consider the effective nuclear charge for manganese. So for manganese again it is 25, number of proton is 25 minus the number of inner electrons, that will be same as 18. So it is 7. Okay. So the effective nuclear charge for chromium is 3D electron of chromium is 6. Effective nuclear charge for 3D electron of manganese is 7. Okay. So what was given in the question? Since the number of electrons of the 3D shell of chromium and manganese was the same or is the same, whether the effective nuclear charge for the 3D electron is same or not. Okay, now we have got the answer as 6 for chromium and 7 for manganese. That means the effective nuclear charge for chromium, the 3D electrons of chromium and manganese is not the same. That means that statement also is false. So we have got 2 false. Okay, is it clear? So I'll explain once again. The chromium configuration goes like this. For manganese, configuration is like this. We have to find out the effective nuclear charge of 3D electrons. 3D electrons. Okay, so what is the effective nuclear charge? Effective nuclear charge is nothing but atomic number minus sigma. Sigma is nothing but number of inner electrons. Okay, so for chromium it is atomic number 24, number of protons 24, number of inner electrons 18. 24 minus 18 is 6. So how you got 18? 2 plus 2 plus 6 plus 2 plus 6. Okay, now for manganese it is 25 minus 18, it is 7. So the effective nuclear charge for 3D electrons for chromium is 6 and effective nuclear charge for 3D electrons of manganese is 7. Okay, that means the second statement is false. Now we are going for the third statement, which comes like this. Multiplicity of Fe is equal to that of Ni2 plus. Multiplicity of Fe is equal to that of Ni2 plus. So multiplicity is nothing but spin multiplicity. Spin multiplicity of Fe and spin multiplicity of Ni2 plus are equal. So we have to find out the spin multiplicity of Fe and Ni2 plus. Now Fe, we know atomic number 26. We are going for the configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d6, 4s2. So this is the configuration of Fe. Okay. Now we are going for the configuration of nickel. Nickel atomic number 28. 1s2, 2s2, 2p6, 3s2, 3p6, 3d8, 4s2. This is the configuration of nickel at ground state. Now we have to find out the multiplicity of nickel, not nickel, nickel 2 plus. So what is Ni2 plus, Ni2 plus, Ni2 plus, Ni2 plus? That means you have to remove 2 electrons. So the configuration of Ni2 plus is 3p6, 3d8 and the configuration of Fe is 3d6, 4s2. Okay, there is a shortcut to find out the multiplicity of elements, that is multiplicity is equal to n plus 1, where n is the number of unpaired electrons. Okay, where n is the number of unpaired electrons. So in this, how many unpaired electrons that we have to find out? So Fe here, S, P, these inner shells all are completely filled. 4s is also having completely filled orbitals. Now only we have to consider 3D. So if we are drawing 3D, so this is 3d6. Okay, 3D 6. 1, 2, 5 and 6. Okay, so this is for Fe. For Ni2 plus, it will be like this: Ni2 plus d orbital, 3d orbital, 1, 2, 3, 3d. So we have got 8 electrons: 1, 2, 3, 4, 5, 6, 7, 8. So here n value is equal to 1, 2. So for iron Fe, multiplicity of Fe is equal to 4 plus 1. Since n is equal to 4, so you can substitute here 4 plus 1. So 4 plus 1 multiplicity of Fe is equal to 4 plus 1, which is equal to 5. Now multiplicity of Ni2 plus. Here we have got n is equal to 2. So 2 plus 1, which is equal to 3. Okay. So the multiplicity of Fe is 5 and the multiplicity of Ni2 plus is 3. So what was the statement? The value, the multiplicity of Fe is equal to that of Ni2 plus. But we have got different values for Fe and Ni2 plus. That means third statement is false. Okay. Now we'll discuss the last statement. The value of L by N for the last electron of the element having atomic number 57. Okay. The value of L by N for the last electron of the element having atomic number 57. So the element with atomic number 57 is lanthanum. So lanthanum 57. Okay. If you are going for the configuration, 5d1 6s2. So this is the configuration of lanthanum. Okay. So now we have to find out which is the last electron. So this is the last electron, 5d. The value of, now we have to find the L by N value of this. Since this is the last electron, we have to find the L by N value of this. Okay. So L is nothing but azimuthal quantum number. N is nothing but principal quantum number. So L is the azimuthal quantum number and N is the principal quantum number. Now, since it is 5d, N value obviously it will be 5. So N is equal to 5. Since it is d orbital 5d, so the L value will be, you have already learned, it is 2. Okay. Now what is L by N? L by N is equal to 2 by 5, which is equal to 0.4. 0.4. So the value of L by N for the last electron of the element having atomic number 57, which is nothing but lanthanum, is 0.4. Okay, 0.4. So this was the statement. That means this statement is true. Okay, this statement is true. So we have got first one false, second one false, third one false, the last one is true. So our option is option D. Okay, option D, F, option D, F, T. So option D is the correct answer. Okay. So hope you have understood the problem. Okay. Thanks for watching my session.